Okay, so in this video cast, we're going to look at how steam powers robots and basically how robots can be a wonderful platform for teaching steam and integrating all kinds of subjects together in education. So here we see the Boston Dynamics robot doing clever stuff, which just shows where robots have come to. A little bit scary if you watched all the Terminator films, but nevertheless quite clever. This is an autonomous bipedal robot. Boston Dynamics used to be owned by Google, but have now been sold off. So that was actually Atlas, and it was designed to operate indoors and outdoors. It's truly powerful in terms of the amount of manipulation. It's ankles, knees, shoulders, elbows, just like a human would be. And because of the way it's built, it can pretty much go anywhere a person would be able to. It uses hydraulic actuators to move everything, so unlike a lot of the robots that we'd play with in education, using hydraulics rather than using servos. It has, obviously, being an intelligent robot, a whole bunch of sensors, uses a LiDAR array and stereo sensors in its head, which allows it to avoid objects, avoid obstacles, be able to detect things, and do a whole clever thing. In terms of size, it's about 5'9", or about the size of the average female in the UK. So when we look at this in terms of science, or STEAM rather, the scientific part of Atlas is based around its hydraulics, and hydraulics is obviously it's an applied science which uses engineering, chemistry, and a whole bunch of other sciences involving the mechanical properties and use of liquids. So at its very basic level, it's a liquid equivalent of pneumatics. So in other words, you put something under pressure and it will make other things move. Being fluid, it allows you to do a lot more flexible type of movement than perhaps if you were using a straightforward mechanical piece. So obviously in this particular robot, science is covered by hydraulics, but then for the same reason, if you were running an electric powered robot doing battery stuff that's running off batteries, obviously the science involved in the chemistry of batteries and things like that. Technology, well, the technology in Atlas is tremendous. It actually has a double vision system. It has a laser rangefinder, which obviously by the name uses a laser to figure out how far away it is from obstacles, and it uses stereo cameras, both of which are controlled on board, and can allow it to basically detect a 3D image of where it is, so it can do a lot of clever stuff. The grippers or hands, not really hands, more grippers, have very fine motor skills and have feedback, so that as the hand closes, it can detect it's closing on something. Obviously nowhere near as sensitive as human skin, but it can allow it to very carefully pick up things like eggs and other fragile things. The combination, going back on the vision side of it, the combination of stereo cameras and laser range finding allows it to not only interpret what it sees as an image, but also to embody that in a 3D depth, so it can actually figure out potentially ways around objects and how to pick where something is if it's trying to pick it up. From an engineering side, obviously a lot of mechanical engineering in there. It's a bipedal robot. It needs to be able to have that range of motion that a human would do. Obviously, there are robots aimed at education, like the mechanoids, which don't actually have range of motion in the limbs. They just roll around on wheels and the arms move. In this instance, it has fully functioning hip, knee, and ankle joints, and those joints have to be capable to be able to support the full weight of the robot, which without a load is about 80 plus kilos. And not only do they have to be strong enough to support it, but they have to be robust enough to be able to do this repeatedly, many hundreds, thousands of times, just like a human would be. In terms of art, well, you know, the design of a robot quite often suits its purpose. And it may be that you want to build a robot as a caring device for use in a hospital or in a nursing home type thing, and you don't want something that looks particularly ugly or something that looks like a refrigerator, because it's going to put people off. So if you have it looking familiar, like a humanoid, or even just building the sensors into it so they're reminiscent of a face, all those kind of things help. And obviously, as we put in here, form will follow function. What you're trying to do with it will allow you to decide what it's going to look like. On the creativity side, when you start to look at how you're controlling this robot, the application that you're using to control it needs to be approachable by more than just the guy who built the robot. So it needs to be simple yet powerful, and the ability to replicate what the robot looks like on a screen and be able to manipulate that is something that's particularly clever. On kind of an offshoot from it, you also have marketing as well, where you need to have, if you want to sell something, obviously the least you need to do is to be able to have a photograph of it. You need to write about it. You need to be able to explain to people what is unique about your product. So the whole range of creative skills, from English language arts to photography, animation, videography, all that kind of stuff comes into it. So robots are quite clever for using a lot of stuff. Then we have mathematics to make up our steam. Obviously, there's an awful lot of calculations go on. You need to be able to figure out how to move, where you are, what you can see, and when we look at all the stuff that's there in terms of the stereoscopic vision, the laser rangefinder, all those are going to come back with numbers, and all those numbers are going to mean something to, mean something to the robot, means something to the controller of the robot as to where it is and where it is particularly relevant to other things. So being able to calculate all those are particularly useful. So there's a lot of mathematics goes into that. Also, when you're designing a robot, you have obviously you can design the best looking robot in the world, and if you power it by a single AA battery, it's not going to go very far. So what you need to think about is whether you're going to how much battery power you need, how big a battery, how much extra space you need for the battery. So there's a whole bunch of calculations that come into designing a robot that you would actually need. So looking overall in terms of careers and things that you would need for working with robotics, obviously chemical engineers would be working to design batteries. Also perhaps they would be working with hydraulics, being able to find the right fluid to be able to create the right pressure. Electronic engineers would be working with sensors, everything from the cameras to touch sensors in the hands for being able to pick things up. Programmers for setting up the onboard software controls for an application to control the thing remotely. Artists would be providing concept design, images, potentially marketing materials, all that kind of stuff. Physicists would need to be aware of lasers that would give it a laser rangefinder capability. Things like gyroscopes to be able to make it keep balanced, all that type of stuff. A mathematician would be really useful in terms of power usage, perhaps how big a pump you would need for the hydraulic system to be able to work correctly, to be able to lift a certain object, to be able to calculate the carrying, the lifting capacity, the speed, all that type of thing. A hydraulic engineer looking at the pumps and the pistons that actually make things move, figuring out how big they need to be, and then obviously there's a bit of mechanical engineering comes in when you start to look at that. Well, okay, how do we make a strong, light piston? How do we make stronger pumps and stuff like that? A mechanical engineer has to look at all the joints that are in there, and not just designing it from a first point of view of to give it the amount of rotation or movement that it needs, but also the ways of being able to make that movement be infinitely repeatable, so that you give your robot a long life. So pretty much everything in STEAM can be done by a robot, or is involved in producing a robot, and there are lots of careers that are built into using robotics.